Hey guys, so we'll be talking about velocity time graphs now, and we will see how we incorporate some of the things that we have learned before into the velocity time graph now. So we're talking about velocity time graphs, and we have learned how to calculate a gradient. So, and we have seen that if we have a distance time earlier, we have seen if we have a displacement time graph and we find the gradient at a point, we will get its velocity. What about velocity time graph? Well, if you guessed it right by now, the gradient of a velocity time graph gives you the acceleration at that particular point. And there's one more. This is the first thing that we can get from this. The gradient will give us the acceleration. Also, the area under the curve will give us the displacement. So if we have a velocity time graph from our observation, first thing that we can find from our observation is its velocity, and we can make a scenario for ourselves. The second thing will be finding the gradient to make sure we know about the acceleration by gradient. The third thing would be the displacement by finding the area under the curve. I'll tell you how to find the area under the curve in the next example. So we can find all the three things from a velocity time graph. Let's see how we do this. Let's take a simple example. Let's take a simple example here. This is the velocity time graph. This is the axis. This is the velocity in meters per second. This is time in seconds in this axis. This is a simple graph here. This straight line. We have done this one. This is the very simple examples that we always do. So we understand some of the things from here. This is 6 here. This time is 2. This time is 6. And this time, let's say, is 8. Now, first of all, from the observation, the first thing that we are trying to find out is the velocity from the observation. So what's happening is this car or anything is at, this is 0. At time t is equals to 0 seconds, this is at rest since its velocity is 0. So its velocity at this point is 0. Now we have the information. Now we can see the velocity is increasing. The height is increasing with an increase in time. So we can say there is an increase in height with the increase in time. So time is equals to 2 seconds. At time 2 is equals to 2 seconds, the velocity comes to 6 meters per second. Now we can see there is a straight line from 2 to 6, which means the velocity remains the same. The car is moving. It's not at rest because it's a velocity time graph. This part shows the velocity. It's not at rest, but it's moving at a constant velocity. So from time t is equals to time 6, velocity remains constant, which is 6 meters per second. Velocity will stay the same. And till 8 seconds, the velocity decreases. The velocity is decreasing and it's finally coming to a rest since the velocity is becoming 0. So at time t is equals to 8 seconds, the velocity becomes 0 again, telling us that this comes to a rest. Okay, so you can make this picture in your mind. It's starting from here, it's increasing its speed, then maintaining its speed, and then decreasing its speed till it comes to 0. This is the first observation that you are having by just looking at the velocity time graph. Second observation that you are supposed to have is through the gradient about the acceleration. So let's see. We have three different lines having different gradients, so we'll consider them differently. Always remember, whenever there are two lines having different gradients, we'll consider them differently. This is part A, part B, and part C. So first, acceleration of part A will be given to us by the gradient of this point. This will take just 2 points here. We know the way to find out a gradient. One point is 0 and 0. The other point is 2 and 6. So acceleration becomes 6 minus 0 divided by 2 minus 0. y2 minus y1 over x2 minus x1. This becomes 6 over 2, which is 3 meters per second square. Since the gradient is giving us the acceleration, this means that initially its velocity was 0, then it accelerated from 0 time t is equals to 0 to time t is equals to 2, and having an increase in velocity of 3 meters per second every second. We can see the first second it would have gone from 0 to 3 seconds, so 3 meters per second in 1 second, and the second second, it is looks weird, but still the second this goes to from 3 to an increase of 3 meters per second in the velocity. This comes to 6 meters per second. So this is all logical. Now, gradient of part B. We all know the gradient of a straight horizontal line is always 0. So if you want to calculate it, you can. The points would be 2 and 6 and 6 and 6. So the gradient, if you want to check this, the gradient would be 0, which means it has stopped accelerating. And we know that the acceleration is only 0 in two cases. One, that the object is at rest, or it's moving with a constant velocity. From our earlier deduction, we can see that the object was moving at a constant velocity in this time interval. So this is logical. Physics is working. So it has a 0 acceleration. Now, acceleration at point C. Again, gradient of this line. Now the acceleration, you can see the acceleration will be constant through this line. The acceleration at this point will be the same as the acceleration of this point, because it's a linear line and the gradient remains the same. Even over here, the acceleration will be same for the 2 points. Even considering any 2 points, the acceleration will be the same. That means through this interval, the acceleration would be the same. Let's see. I can deduce that this is a negative acceleration. This is a negative gradient since it's coming from top to bottom. So this is a negative acceleration or a deceleration. Let's see. Let's just take 2 points, 6 and 6, the first point here, and 8 and 0. Let's just find the gradient. y2 minus y1, 0 minus 6 divided by x2 minus x1, 8 minus 6. This would be minus 6 divided by 2, which becomes minus 3 meters per second square. Now again, the magnitude is 3 meters per second square, but the minus shows that it is decelerating now. It's coming from a greater speed, it's now coming to a lower speed, as in you were pressing the brakes of the car. So now it's coming to, the acceleration is minus 3 meters per second, or I can write the deceleration is 3 meters per second square. So if you write the deceleration, you don't need a minus sign because it means the same thing. So a deceleration of 3 meters per second square. So this is coming down. So if you see the gradient means minus 3, this means that with every increase in the x, there is a decrease of minus 3. So you can see that for example, for 7, this would come from 6 to 3. There is a decrease of 3 in y because of the minus 3 for every increase in x. For 1 unit increase in x, there is a decrease of minus 3 in y. So it's coming down, and in the next second this would be 3 here, and the next second it would be 0. So we know that this is decelerating here. It is changing its velocity from a greater velocity to a lesser velocity. So it's simply decelerating. Now this is done, but we still have a third part. Third part to it, okay. Let me make the graph again, just raise it by mistake. Okay, so this is 2, this was 6 if I remember correctly, and this was 8, and this was 6 again. Okay, so this was thing that was going on. I don't remember correctly. If this is the thing, then let's take it this way. This is meters per second against second. This is a velocity against time. Now, the third thing, we can also find out the information of the distance from the same thing, which is the area under the curve. Since all the lines are having different gradients, we will just see the area, and what we have to find here is this area, taking this as the length and taking this as the height. We have to find this area. Now there are two ways to find this area. Let's see. From this, let's just divide this in sections. Let's say this is section A. Okay, this is section B, and this is section C right here. Let's find the distance that it has moved in the first 2 seconds. Distance moved in 0 to 2 seconds. Now, how to find the area? This is a triangle, so you simply have to find the area of a triangle. And area of a triangle is, if you know from your math lessons, half base times height. So let's find out the area. This is the base, the distance here is 2, and this is the height, this is 6. So half times 2 base times the height, 6. This will give me, you can use a calculator, this will give me 6 meters, as in the area of this portion only, this triangle only, which I labeled as A. So in 0 to 2 seconds, it traveled a distance of 6 meters, and we have seen from the earlier videos, it did travel 6 meters. With the same graph, did travel 6 meters. But now the case is a little different here, but from 0 to 2, it traveled a distance of 6 meters. Now, from 2 to 6, let's find out the distance the car traveled, from 2 to 6. The car traveled again, we would find this by the area under the curve, which is part this thing here. This is a rectangle. So the area of a rectangle, the formula for area of a rectangle is simply base times height, which gives me base is 6 minus 2. This distance, this is 4, and this distance is 6 again. So 4 times 6. This is 24 meters. So the car traveled a further 24 meters from the original point. Till 2 seconds, it traveled 6 meters. From 2 to 6, it traveled 24 meters. Now see how much area it travels, how much distance it travels from 6 to 8. Let's see. Okay, this is again a triangle, so the same formula applies, half base times height. So half times the base, this distance is 2, and this distance is, the height is 6. Again, 2 times 6. This again gives me 6 meters. So this again traveled a distance of 6 meters further while it was decelerating. As we saw, while it was decelerating, it traveled a distance of 6 meters. So this was 24 meters, this was 6 meters, and this was the total distance traveled by the car was 6 plus 24 plus 6, which is equals to 24 plus 12, 36 meters. So in all this, the car traveled a distance of 36 meters. Now, if I wanted total distance, I could also do one more thing, that if, for example, this is the same thing, there's also one more technique to it. If this is 6, this is 2, this is 6 and this is 8. If I want the total distance traveled by the car, and this is again a velocity time graph. So we know the total distance traveled is simply the area under the entire graph. So since they're saying total distance, so we will consider the entire distance here. This entire thing. Now you can see that we can divide it in sections like we did earlier and find out the total area, add all the areas up, or we can just take it as a trapezium. So the area of a trapezium is given by half sum of parallel sides times sum of parallel sides times height. So in this case, these are the two parallel. This is one parallel side and this is the other parallel side, and this is the height. So we can simply use the same half times sum of the two parallel side. First parallel side is from 0 to 8. 8 plus this is another parallel side from 2 to 6. 4. So 8 plus 4 will give me 12 times the height, which is 6. So half, times 8 plus 4, which is 12, times 6. Now you can use a calculator, or we can do it mentally. 2 times 3 is 6. 12 times 3 is 36 meters. Again. So the total distance traveled by the object in the 8 seconds is 36 meters. The case would be a little different. For example, if it just told me, just want to erase this to this little part. Yes. So if, for example, I have the same graph, it's taking too much time. Okay. So if the case is the same, and this is the same graph, this is 2, this is 6 here, this is 8. They ask me, the question says, find the distance traveled. Okay, the distance traveled in 6 seconds. In the first 6 seconds. Now I will only consider the area under the graph till this point, not this point, because they haven't asked for it. So the area I'll be considering would be this one. Now we have seen this was 6 meters and this was 24 meters. So we can just simply do 6 plus 24 is equals to 30 meters. Or we can also see that this is again a trapezium, so you use the same method, half times sum of parallel sides times, this is a notation for parallel sides, this is sum of parallel sides times height. So half times, now in this case these are again the two parallel sides. This is from 0 to 6. The first parallel side is 6, the second parallel side is 4, the height is 6. So this becomes 6 plus 4, 10. So half times 10 times 6. If you find this is 2 times 3. 10 into 3 is again 30 meters. So guys, you've seen that from a velocity time graph we can find the information about the velocity, the acceleration, and also the distance it has traveled in that particular time interval. So guys, we'll be looking at some more complicated examples of this. So stay tuned to it, and thanks for watching.